Welcome to Mastering Solutions. In this question, we're told that with this salad dressing, we have this interface here, and down here on the bottom is going to be the water. Since it's more dense, we have N is 1.33, and the canola oil, since it's less dense, the oil, that has an index of refraction of 1.47, the question says. So now we need to figure out what is the critical angle. And if you remember from the critical angle, the index of refraction for the bottom angle needs to be the one that is larger in order for it to work. So what they're talking about is they say, you notice a silvery reflection of light from the boundary. So the light is coming in here, and then they're saying that we get some internal reflection. And so we need to figure out what the angle is from the normal. So this right here, this is what we're trying to solve for. These two are equal to each other. And that formula, of course, is theta sub c is equal to the inverse sine of n2 over n1. So like I was saying, the n1 needs to be larger than n2. Otherwise, you'll get a domain error in your calculator. And if you understand the principle of the critical angle, you understand that that doesn't work, because if it was larger on the top, then we would just get refraction because we'd be going from a low to a high, and so it would refract through. Or the other way, if we went from a low to a high this way, we would just get refraction. And so we can just plug and chug. So we have inverse sine of n2 is going to be the 1.33 over 1.47. And so theta sub c, inverse sine 1.33 divided by 1.47 gives us an angle of 69.8, or excuse me, 64. So 64.8 degrees. So that is the angle that we get for the critical angle for the water and the canola oil.